So welcome you all for the lecture. In The topic of the lecture is carbenes, carbanions, and free radicals. So in this lecture, we will discuss about the carbenes, and free radical. Before this, we will go with some of the some of the basics about the intermediates, because these all are the intermediates. So here, if you see, the content of the topics is reaction intermediate, among them carbene, their generation, structure, and stability, and carbanions. And in carbanions, you can see here, uh, if you see, these are formation, structure, reaction involving carbenes. Free radical, we will discuss about the free radical. So free radical is also, here we will discuss about their important reaction, generation, and the structure. So here you all might be aware of that. Intermediate, because these are the intermediates all. So these intermediates, these are the atoms, ions, and molecules with a lifetime appreciably longer than a molecular vibration, that is formed directly or indirectly from the reactant and reacts further to give either directly or indirectly the process of chemical reaction. So these are the intermediate which form during the course of a reaction. So during the course of a reaction, they plays a very important role to decide the formation of a particular chemical products. So these intermediate are having very crucial roles during the chemical synthesis. So here, if you see, so now from here you can understand the intermediate. Like here it is given in a form of animation, like different free radical kind of reaction. You all might be aware of that, because those reactions are very important during the polymer synthesis. So free radical, because that is also an intermediate. So like the other intermediate, here you can see how does these free radicals helps to make a bigger molecule. So here, like it is a example is given, ethylene C double bond C. So this break down in a radical first due to the free radical reactions. So these free radicals are intermediate during the course of reactions, and after the formation of free radical, they makes a very long chain, and you can see how does they are adding to each other and making a very long chain, which is having thousands and millions of having the atoms and molecules in that chain, and makes a polymer structure. So this is having what is the importance of these, like it is only the one intermediate which is like free radical. So there is free radical reaction is takes place in case of the polymerization process. So this is very important when we are making like polythene, for polyvinyl chlorides, and vinyl chlorides. There are so many products can be synthesized by the use of these starting material and these reacting material. So free radical, as you had seen, as a one of the the product, one of the intermediate which is making lot of you can say having a very great application in the field of like styrene. So these all are getting through the free radical reactions in the polymer industry. If you see, so you can understand why these intermediates are very important. Even though in the case of synthesis, in a common organic synthesis, during the formation of different kind of medicine, different kind of to add the substituent on a groups, so these reactions are very important and very crucial once we are discussing about these kind of reactions. So likewise, like carboniamine, carbanion, carbocations, and these ions are also equally important, because they also helps to make the different kind of products and reactions. So now coming to before going to carbanion and carbenes and free radical, which is the lecture of the topic, here you have to be some prior knowledge of carbocation. So here carbocation, you all might have know, is having electron deficient species, so represented by this structure and having planar planar structure and sp2 hybridized. So these carbonium ion are trivalent trivalents, positive species like methyl positive, ethyl positive, and pentavalent positive species. So these are the general structure which is looks like here. If you see triphenyl, methyl, three different phenyl groups are there. And if you see their hybridization, you can see the hybridization is sp2 hybridized. So there are many more example is there which you can see how the carbocation is being formed. So these are having a very great importance during the course of reaction. If you see their formation, there are number of techniques for the formation of these. So here you can say by the halide, alkyl halides, you can synthesize the carbocation. And likewise there are number of other reaction like alcohols, like methyl alcohol and other. So you can also produce these kind of species. Here you can say like from the different amino groups, if are amides, are sh. So from these type of starting material you can also synthesize these carbocations. So there are a way of formation of this. So they can react with the nucleophiles if it is having any in a reaction in a nucleophilic group, so they can get attached with the nucleophile. So some carbocation act as a Brown state acid to lose the proton. So here you can see some are losing the proton and keeping their electrons. So they are releasing a proton, so acting as Brown state acid as well. So here stability, if you see the tertiary carbocation is more stable than secondary and primary. So this is due to the hyperconjugations. You might have some idea about the previous classes and from the previous lecture as well. So here these are the the compounds which is having very great relevance with respect to once we are talking about the carbocation. So their stability also depends upon the number of hyperconjugating structure which is having the more in that case. So here in a case of like tertiary, you can say also in case of tertiary carbon and secondary carbon and primary carbon. So accordingly their stability is being decided and they are having the more stability. So now coming to carbanion, the carbanion is an anion which the carbon has an unsaid pair of electron. So this is having Bs a negative charge, usually with the 3 substituent for a total of the 8 valence electrons. So formyl, like formally if you say a carbanion is the conjugate base of carbon acid. So here if you see this carbon is attached with the alkyl group and this is attached with another groups. So here you can say there is a one lone pair of electron. So this is carrying negative charge. So here this is like a conjugate base, you can see. So stable carbanions to however exist, although in this most cases they are reactive. So there are many reaction in which the carbanion, you can say here in this reaction, here it is also like crown ethers, if you have idea about this. So these are the crown ethers. So here with in the presence of this molecule which is having triphenyl groups, so they are in presence of n-butyl lithium and tetrahydrofuran. These are the reagents. So this is making this carbanion species. So these are the formation by which these carbanion species can be synthesized. So here they can make a ionic bond with the lithium which is present in a reagent butyl lithium and butyl lithium. So this is a carbanion formation here in case of triphenyl groups attached in this compound. So by this way they can be also generated by the different of different reaction and their reactions you can see here, like by replacing the hydrogen from the from the hydrocarbon, because this is the hydrocarbon chain R, and this can be generated from there also. So a group attached to the carbon leaves without its electron pair, because here hydrogen is removing or from this by the leaving their electron to this carbon. So then these can be formed. So a negative ion adds a carbon-carbon double or triple bonds. So now you can see here, like from this group, so this can also RCO. So here this R is being replacing by taking the electron due to the electron density moving this direction due to the high electronegative atoms. So this is also making a carbanion. So there are number of methods by which these can be generated. These reaction can be, or carbanion can be generated. Likewise here you can see these groups can, if there is any negative or nucleophile kind of groups is attacking with a particular carbon, so the electron will shift towards this carbon. So this will also make a carbanion species, which is this carbon. So here you can see there are many more examples for this, like alkyl chlorides in the reaction with lithium and with magnesium. You can see that these can give such kind of, reduce the strongly reduced metal like lithium, and sodium or magnesium can convert alkyl halide to alkyl sodium or alkyl lithium. So here if you are reacting with the sodium, it will make a alkyl sodium, or if you react with the lithium, it will make it these kind of compound. So other there are many more examples of the reactions which the carbanion takes place. So here the carbanion can react with the alkyl chloride and can make the alkyl chain. So this is the hydrocarbon chain will be formed up, and finally, so it means this is having the application for also the formation of the hydrocarbon. So you can synthesize the hydrocarbon as well. So this is having the great another application for the hydrocarbon industry, because the hydrocarbon industry is having very great role for the formation of different kind of polystyrene polymers and hydrocarbon, like gaseous fuels. So even for these kind of synthesis, and many more products can be synthesized in biorefinery industries. They are having very crucial role. So here similarly this kind of reaction, you can see this is the carbon and carbon. So this can bromine with reacting with the bromine, they can add the bromine from this side. So bromination can takes place by this way. So this is having another one excellent example. So in case of the carbanion may undergo catinotropic 1,2 shift to give a rearranged product. So here you can see how does the 1,2 shift is being taking place. So you can see here this group is shifting over here. And this is, this is here, you can see here. So this is just this carbon is getting over here. You can see here this methyl is now attached with this phenyl group. So this kind of shift is also rearrangement type of shift, you can say, is rearranging over here in this. So the carbanions may oxidize to free radical. For example, you can say free radical can be oxidized here. So this can make it like this kind of reactions as well. So if you see, in case of stability, the stability of carbanion is directly related to the strength of the conjugate acid. So here you can see the stability order, how the weaker is the acid, the greater is the base strength, and the lower is the stability of the carbanion. So you have to see here, if the weaker is the acid, the greater will be is the base strength, and the lower is the stability of carbanion. So stabilization by the sulfur or phosphorus, other metals can stabilize that carbanion, but that depends upon if it is present in the reaction. So then only that can be stabilized the particular molecules, or carbanion in a molecule also. So if you see the field effect, ylides are the more stable than the corresponding simple carbanions. So carbanions are stabilized by field effect if there is any heteroatom. Means if there are any heteroatoms, so carbanion are stabilized due to the field effects uh, connected to the carbanion, ionic carbon. So provide that the heteroatom bears a positively charged in at least one important canonical form. So here you can see how does these changes are being can takes place. They can exist in different canonical forms. So even though they can be having this kind of effects, field effects also that particular carbanions on the presence of heteroatoms. So stability, as we said, so conjugation of unsaid pair of electron with an unsaturated bond. So here you can say unsaturated bond, you can conjugation if they are in a conjugation mode. So like here the conjugation is possible. So they can also stabilize the carbanion if there is a conjugation. So similarly here you can say there are number of conjugating structure is possible. So that in that case that carbanion will be more stable. So if you see in a different group, so like in a triple bonded compound will be more stable than second double bonded and aromatics, carbanion and RCS2 simple alkyl. So carbanion increase in stability with increase in the amount of S character. So you have to see if there are higher the S character, so there will be the more of the carbanion will be more stable. So here in triple bond you can see, and different other groups you can also check their S characters. So the accordingly the that particular species of carbanion will be more stable. So carbanion factors, there are number of stability and reactivity which like inductive effects, hybridization and extent of conjugation, and the so electronegative atom adjacent to the charge will stabilize the charges. Obviously this will inductive effect. In case of inductive effect, hybridization, charge bearing atom, the greater is the sp3 character or sp character of the charge bearing atom, the more stable the anion. So the extent of the conjugation of anion, resonance effect and stabilizing of the anion also will stabilize the molecule. So how to detect these carbanions? There are a number of techniques like NMR methods, nuclear magnetic resonance spectroscopy, ultraviolet visible spectroscopy. So these are some of the important techniques by which a visible spectra can also determine the starting compounds, and trapping way, the method of trapping of the carbanion with an electrophile is another way of to detect the carbanions. So there are the most advanced technique you can see here like nuclear magnetic resonance, ultraviolet spectroscopy. So now carbene is another topic which is very important also. So here a carbene is highly reactive species containing a carbon atom with 6 valence electrons. So having the it is having the 2 electron less from their octet. Having the general formula, it is represented like Rc, and here is a lone pair of, you can say, the electron which is having either triplet state or either singlet state. Singlet state means the electron will be resides in one orbital in anti-parallel to each other, or having the net dipole will be 0. But in case of triplet carbon, so they are having a parallel movement in a different orbital with parallel spin. So here is net spin will be there. So the total spin in case of this, if you see the singlet carbon, it will be 0 because this will cancel out. So there is a net one spin is there, either it is a clock or anti-clock, whatever the direction, but there is one net spin is there. So these kind of species will be always paramagnetic, and these will be no anti, you can say these are not paramagnetic, diamagnetic especially. So other property can this kind of species, because these are the free radicals, so electron spin resonance techniques can be very useful to identify the triplet carbene. So these are the detection methods once we are talking about the detection. So electron spin resonance, which is generally called ESR as well. So here already we have discussed here the carbon atom in a singlet carbene is sp2 hybridized. So you have to just keep in mind what kind of hybridization is there. And carbon in shape of carbanion, if you see, this is a planar structure, it's having a planar shape. So p orbital sp2 hybridized is having this kind of electron in case of triplet carbon. So this is another very important now generation. There are number of reactions by which it can be generated. If you see like this reaction in case of diazoalkane. So with the help of photolysis in presence of light, you can generate the carbene. There are many more example you can refer. So these are the another reaction by which you can also synthesize or you can generate the carbene. So these carbenes are having very great relevance and reaction in so here also with the help of base induced elimination you can also synthesize. Carbene are is an intermediate in Wolff rearrangement reactions. So in case of this, you can see here the carbene is being forming in during the intermediate state. So this carbon is the carbene, uh, among this whole molecules. So this carbon I am talking about. So here this is the intermediate in case of Wolff reaction. So you can see here how does the the nitrogen is getting to be removed from this overall molecules, and this is making the attaching with here some alkyl groups. So these are having the importance in very other reaction like Riemann reactions. Here you can see the in a case of Riemann reaction, because this is helpful in the salicylic formation. So you can synthesize the salicylic with the help of this this reaction. So Riemann reaction also is very important example for once you are talking about the carbene, and so this is also goes with the carbene formation reaction, because here this CSCl3 trichloromethane, this makes a carbene species in between the then it reacts only with the ortho position, and further after the reaction with base it makes a aldehyde group here. So salicylic formation is taking place. Detection, as we said, electron paramagnetic resonance spectroscopy, which is generally known as electron spin resonance spectroscopy. UV visible spectroscopy also very helpful. So these are some of the important techniques by which it can be, you can detect the carbenes. Now the another topic which is very important also is a free radical. So here the free radical maybe is defined as that contain one or more unpaired electrons. So radical plays very important role in combustion. If you talk about the application, there are number of applications, as I said in a previous in the starting, because in a polymer industry there are any of the polymerization, so there are free radical reactions, so they are able to make a very lengthy molecules, very lengthy. So like a polymer, daily use of polymers, you are using the polymers in polythene for plastics and many more items like pipes and all are having goes through these free radical reactions. So like in combustion in transport sector, once you are burning the fuels inside the chamber, so there is these kind of reaction also takes place. So there is also free radical formation is takes place. So when these free radical forms, you might be aware of that in a atmosphere, ozone depletion, because this is due to the free radical reaction only, because in the presence of photolysis or during the sunlight, the ozone is getting to be affected, is decomposing on the radicals. But these free in a stratosphere, the radicals which is forming, at the same time they compensate the ozone density. But once if there is any pollutant which is act as a catalyst to enhance the rate of reaction of the breaking down of the that helps to broken up the ozone molecules into O2 and nascent oxygen, or you can say O radicals. So then the ozone depletion or ozone hole, which is the literal terms, was generally used by the environmentalist and from the climate expert. So that is also goes through these free radical kind of reactions. So many other polymerization reactions, plasma chemistry, biochemistry, and chemical process, including human physiology, also these reactions are goes through. So as I said, the free radical reaction is very important. So there are number of other reactions you can check with various reaction are there. So here a carbon based free radical is trivalent carbon species having p electron in the valence cell. So here you can see like these are the species which are free radical. So here you can say trimethyl group is there in this compound. So this is the free radical. This is formed by the photolysis in general, and even you can see many other methods by which it can be formed. So here this is the another species. So if you see the sp3 character, so this is increased from this direction to left hand direction, and sp2 character, if you see this is increased from left to right. So B essential of all alkyl radical are planar. It is just the relative differences. So there is to check the planarity, because the sp2 will be if that is the planar structure. So then the stability order will go towards the left to right, and otherwise if it is sp3 then it will increase from right to left direction in case of a such kind of examples if we see as we see here. So now the free radical generation, as I said, heat can also help us to generate this, and by the photo light or by the sunlight you can also make this by other. You can see here bimolecular redox reaction also generate free radicals. For example, here there are different bimolecular redox reaction in which the free radical can be generated. Here you can see the phenyl radicals. Similarly, stabilization is also very important because these resonance effect due to the conjugation stabilize the free radical. So here you can see the resonance. If you can make the number of resonating structure, so free radical can be more stabilized in that case. So there are number of this kind of reaction is there. So here also in case of aromatics you can say how much the resonating structure or kind of conjugation, different kind of resonating structure if you can frame out for the particular molecules or particular species, then their stability can be stabilized, that radical can be more stabilized. So similarly here you can see in case of aromatics, in case of aromatic compound, that is will get more stabilized like in this kind of species. So here free radical reaction, these are very important as I said already in previous in the starting. You can see also here these are free radical often takes part in a radical propagation reaction. So they propagate the reaction also. So here you can see phenyl, and this is making a free radical species over here. And you can also check here like RCS2 dot is further reacting with a chlorine, making a alkyl halide, this alkyl halide, and leaving behind the chlorine radical. So it means one radical if it is comes and having, if there is certain interaction with other molecule, so that molecule will get also converted into the radical. So here you can say this is the neutral species, this chlorine, but after in presence of this kind of radical like in RCS2 radical, so it is changed to chlorine. So similarly, similar kind of reaction takes place in ozone like chlorofluorohydrocarbons and ozone depleting substances, freons. These all go with the same kind of reaction, and they degrade the density of the which is the dapson is the unit of ozone in the stratosphere. So similar kind of reaction takes place in the stratospheric ozone. So that's why these refrigerating agents is also enhancing the rate of degradation of the ozone thickness over the stratosphere. So here many more if you see in some cases the free radical itself may be fragmented and trigger the propagation of a chain reaction. Here you can see after itself fragmented and getting to propagate the reaction, and reaction is getting to be increasing, again this molecule is attaching with this another molecule of the because and making a longer chain of this. So the suitably submitted free radical may isomerize, and if it is suitably substituted, so they can isomerize. Here you can see this can take this hydrogen, and a methyl group is being formed, and this takes the shape of another molecule. So this kind of arrangement and substitute, if they are properly substituted, so isomerization is also possible in such kind of species. So deprotonation and radical coupling are the common reactions of the termination of free radicals. So here you can disproportion and radical coupling. You can check here disproportion reaction and radical coupling means the both the radical are just coupled and making a neutral species. And disproportion you can say here like they are just disproportionating, they are just transferring the one of the hydrogen to the another species, and this electron this bond is shifting, this radical is making a bond with this radical. So this kind of reaction is disproportion reaction. So here you can say this is converted into this neutral species, this is also converted into ethylene species and also a neutral species. So now they can be also detected by the free radical, can easily detected from the ESR. They can also detect it from the UV visible spectroscopy, and here there are number of other techniques by the in NMR spectroscopy can detect the free radical by studying the Oberhauser effects, and these are the some of the important techniques which is very useful to detect the free radicals species. So free radical can be easily detected by this method. So now overall, if you see the discussion what we had made so far, we discuss about the carbines. These are different intermediates. Among them, how to generate them, how to make the carbanions, what is their special, stability, their reactions, and similarly in case of carbines, their formation structures, radicals, and free radical reaction, and how does the free radical reaction is takes place, how the importance are having these free radical reaction in case of you know different kind of reaction in industry as well. So these free radical reaction are very important, their reaction, their rearrangement, we also have some discussion on the topic. So these all material has been taken from the different sources, internet sources, from the other sources, different textbooks. So this has been taken from various internet sites. So this text material is only, or this instruction material is for only instruction purpose only. So here, thank you for watching this video and listening this video lecture. Thank you so much.